Hello, I'm Sebastian. Welcome to 9 Trees podcast. Today, I will summarize and review the book. Understand Physics, Teach Yourself, Master Physics Step by Step by Jim Breithaupt is a structured guide for building a solid foundation in core physics, aimed at learners who want clarity without losing rigor. The book's appeal lies in its teacherly approach. Concepts are introduced in manageable stages, explained in plain language, and reinforced through worked examples and practice-style questions. It covers the central ideas that typically appear in school and early college syllabi, helping readers move from basic measurements and motion to energy, waves, electricity, and modern physics themes. Instead of treating formulas as magic, it focuses on what the quantities mean, how relationships are derived or justified, and when an approximation is sensible. This makes it especially useful for self-study, revision, or filling gaps before an exam. Readers who have felt overwhelmed by abstract explanations can use its step-by-step progression to rebuild confidence and develop problem-solving habits that transfer across many physics topics. I will give you key takeaways from this book. Firstly, foundations, quantities, units, graphs, and scientific thinking. A major strength of step-by-step physics learning is starting with the toolkit used everywhere else. Breithaupt's approach emphasizes the language of measurement, physical quantities, SI units, prefixes, and the idea that careful definitions prevent confusion later. Readers are guided to treat dimensions as a built-in error check, so that equations make sense before any numbers are substituted. Graph skills are also central because many physics relationships are revealed through gradients, intercepts, and curve shapes. Building comfort with interpreting motion graphs, linearizing data, and recognizing proportionalities supports later work in mechanics, electricity, and waves. This topic also encourages scientific habits, stating assumptions, selecting appropriate equations, and understanding uncertainty and significant figures. Even if a learner can plug into formulas, weak foundations often cause mistakes such as mixing units, misreading axes, or misinterpreting what an answer represents. By focusing on the basics of measurement and representation, the book prepares readers to learn new content faster, communicate solutions clearly, and diagnose errors logically rather than guessing. Secondly, mechanics made coherent, motion, forces, momentum, and equilibrium. Mechanics is often where students first experience the gap between everyday intuition and physical law. The book's step-by-step method helps reconcile this by separating concepts that are commonly blended together, such as speed versus velocity, acceleration versus change in speed, and mass versus weight. Motion is built from definitions and then connected to graphs and equations, so kinematics becomes more than memorizing SU-Weight-style relationships. Forces are treated as interactions that cause acceleration, leading naturally into Newton's laws and the disciplined use of free body diagrams. This develops a repeatable problem-solving process. Identify the system, list forces, choose axes, write equations, and check limiting cases. Momentum and impulse add another powerful lens, particularly for collisions and short-duration forces, where force-time thinking is clearer than constant acceleration assumptions. The inclusion of equilibrium ideas and moments helps explain everyday structures and turning effects, linking linear and rotational reasoning. Across these subtopics, the value is coherence. Readers learn when to use which principle, how to avoid sign errors, and how to interpret answers physically instead of treating them as algebra outputs. Thirdly, energy and power, a unifying approach to work, efficiency, and conservation. Energy methods can simplify many problems that look difficult in a force-based approach, and the book highlights energy as a unifying theme across physics. Readers typically move from the definition of work to the meaning of kinetic and potential energy, then to conservation arguments that reduce multi-step motion problems to a few key states. This topic also clarifies the difference between energy transfers and forces, addressing common misconceptions such as energy being used up rather than transformed. Power and efficiency provide a bridge to real-world applications, helping learners quantify how quickly energy is transferred and why no practical device is perfectly efficient. The book's style supports good habits like choosing reference levels for potential energy, tracking energy stores and transfers consistently, and checking results against expected behavior. It also strengthens quantitative reasoning by connecting energy to graphs and by showing how units convey meaning, such as joules being equivalent to Newton meters. For self-learners, energy-centered thinking often becomes a confidence boost because it offers an alternative path when force diagrams feel overwhelming. Fourthly, waves, sound, and light. Patterns, models, and measurable properties. Waves are where physics becomes strongly pattern-based, and a step-by-step guide can prevent the topic from feeling like a list of disconnected facts. The book supports understanding by focusing on the basic wave model and the measurable quantities that describe it: amplitude, wavelength, frequency, and speed. From there, readers can interpret wave behavior through phenomena such as reflection, refraction, diffraction, and interference, linking what is seen in experiments to the underlying model. Sound provides an accessible context for longitudinal waves and resonance, while light introduces electromagnetic wave ideas and optical effects. This topic also encourages careful interpretation of diagrams, especially when distinguishing particle motion from wave propagation and when analyzing phase and path difference in interference. Practical problem solving often relies on a small set of relationships, such as speed equals frequency times wavelength, but the book aims to make those relationships meaningful rather than purely procedural. By learning how wave concepts connect across media and situations, readers gain tools that are essential for later study in optics, communications, and modern physics. Lastly, electricity, magnetism, and modern physics, from circuits to big ideas. Many learners find electricity and magnetism challenging because it combines abstract quantities with multi-step reasoning. The book's incremental approach helps by starting from charge, current, and potential difference, then building toward resistance, power in circuits, and common circuit configurations. Emphasis on clear definitions supports correct use of relationships such as those linking voltage, current, resistance, and energy transfer in electrical devices. Conceptual understanding is reinforced by explaining what meters measure, how series and parallel connections change current and potential difference, and why safety considerations matter in practical contexts. Magnetism and electromagnetic induction extend the story by connecting forces, fields, and changing magnetic flux to induced currents, building intuition for generators and transformers. The modern physics elements typically introduce readers to the idea that classical models have limits, opening doors to atomic structure, radiation, and key principles that underpin contemporary technology. By treating these topics as connected rather than separate chapters, the book encourages readers to see physics as a consistent framework for explaining both everyday devices and deeper scientific ideas. In conclusion, this book suits students revising for school or early college exams, adult learners returning to science, and self-taught readers who want a dependable pathway through core physics without relying on classroom teaching. It benefits the reader's life by strengthening analytical thinking and quantitative confidence. You learn to translate real situations into models, choose sensible assumptions, and check results for plausibility. Those skills carry into engineering, health sciences, computing, and many technical trades, as well as everyday decision-making where numbers and evidence matter. It is also valuable for learners who have experienced physics as intimidating because the step-by-step structure and emphasis on worked reasoning can rebuild competence steadily. Compared with many physics books that either oversimplify concepts or present them with heavy mathematical formality, Breithaupt's approach aims for a middle ground, accessible explanations paired with enough structure to solve authentic problems. That balance makes it worth buying as both a learning guide and a revision companion, especially for readers who want a single resource that connects the major topics into a coherent whole. If you would like to support Jim Breithaupt, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.